This lesson is on graphing linear functions from word problems. Samantha's ride to school is 4 minutes more than 2/3 Tom's travel time. Which graph shows the possible times of Samantha and Tom's ride to school? Samantha's ride to school is 4 minutes more than. I'm going to put that in the back like it's a y-intercept. So 4 minutes more than 2/3 times Tom. So Samantha's ride to school is 4 minutes more than 2/3 Tom's travel time. Well, instead of using S's and T's, let's change this to y equals mx plus b. So y equals 2/3 x plus 4. So what we're looking for is a graph that has a slope of 2/3 and a y-intercept of 4. So let's start with the y-intercept of 4. And A has a y-intercept of 4, so we like that. B does not have a y-intercept of 4. It has an x-intercept of 4, but actually the y-intercept would be way down here, negative. So that's not something we want. So we can cross B out. C does not have a y-intercept of a 4, so we're going to cross him out. And D does have a y-intercept of 4. So we're down to A and D, just based on the y-intercept. Now we're looking for one that has a slope of a 2/3. So we're going to go from our y-intercept, we're going to go up to right 3. And that line does not fit. Let's try D. Up to right 3. And that fits. So we're going with D. So take the word problem, translate it into a y equals mx plus b, and then just figure out which graph fits. Bailey's walk to school is 10 minutes less than 3/2 of Alex's walk time. Bailey's ride to school is 10 minutes less than 3/2 Alex. Less than means it's a minus on the 10. So I'm looking for a y-intercept that's a -10. If we look at this one, his y-intercept is a +10. That's not what I want. This one has a y-intercept of a +10. Not what I want. So let's look at these two. This point right here is not the y-intercept. Neither is this one. But remember, our y-intercept is supposed to be a -10. So think about it. If this graph was extended, and again, this is the origin, and this line kept going, would it hit at about -10? And the answer is yes. And let's look at the same thing over here. If this graph was extended, again, this is the origin, and this line was extended, would it hit at about -10? And the answer there is yes. So I like both of these in terms of their y-intercept. And we had to do a little bit of work for that. But again, make sure that you notice that it's a -10 for a y-intercept, so make sure that you go below the origin. Slope of 3/2. So let's go, let's erase this so we can see. So I'm looking for up 3, right 2. I like this point. It crosses exactly, so I can use that. Up 3, right 2 does not seem to fit. So let's try this one. I can't use this point right here because it doesn't cross at an exact point, but I can use this one. Up 3, right 2. Bingo. Christy's ride to school is 3 minutes more than 1/2 Brianne's travel time. Which graph shows the possible times of Christy's and Brianna's ride to school? Christy's ride to school is 3 minutes more than 1/2 Brianna's. So I'm looking for a y-intercept of a +3. So I like this one. I don't like this one. I like this one. And I don't like that one. So I'm down to A and C. I have a slope of a 1/2, which means up 1, right 2. I like that. If we go up 1, right 2, I don't like that. So we're going to go with A. I'm going to skip this one. Abel makes birdhouses. On the morning of January 1st, he had 8 birdhouses left from last year. He makes 2 birdhouses per day beginning on January 1st. Which graph shows how many birdhouses he has in terms of the day of the month in January? Well, how many birdhouses did he start with? He started with 8. He had 8 left over. So we have y equals something plus 8 because he started with 8 birdhouses. Now what's happening to his birdhouses? Is he gaining them or is he losing them? Well, he's making 2 birdhouses per day. So he's gaining 2 birdhouses per day. So positive 2x. If he was selling 2 birdhouses a day, then that 2 would be negative. So I need a y-intercept of 8. So I like that. I like that. I don't like this one. And I don't like that one. And again, remember, he's gaining 2 birdhouses a day, so should your slope be positive or negative? Positive, so your graph should go up. So it can't be G because this goes down to right 1. He's losing birdhouses on that one. This one goes up to right 1. The original value of a computer is $4,000. It decreases in value at a rate of $500 per year. Which graph shows the value of the computer as a function of its age in years? Okay, so y equals, what did it start at? It started at $4,000. So that's my starting value. It decreases in value at a rate of $500 per year. So my slope is 500x, but it should be a negative 500 because it's losing money. It's losing value. So just based on the fact that my slope should be negative, which graph is out? And the answer is H, because H says that we're starting at $4,000 and it's gaining in value, and that's not the case. This one has a y-intercept of 4,000, and so does this one, and so does this one. So they're all still good. Now I need a slope of negative 500, so I need to go down 500 and right 1. We need to take a look at our blocks. Surely I don't have to count down 500 blocks. If you'll look from here to here is 1,000, so that means each block is worth 500. So when it says negative 500 over 1, I need to go down 1 block, and then if you look across your x-axis, if that's 5, then 1 block is 1. So I need to go down 500, which would be down a block, and then right 1. And I don't particularly like this graph. Down 1, right 1. No, it seems to be falling too steeply. So I think F is out. So let's go look at this one. Down 500, right 1. Down 500, right 1. Down 500, right 1. Down 500, right 1. I like that one. Let's look at J. Down 500, right 1. Down 500, right 1. Down 500, right 1. And again, that one's falling too steep. So we like this one. A maid service charges $10 per hour plus a base charge of $20. Which graph shows the relationship between the number of hours and the amount charged? So y equals, they charge $10 per hour plus a base, that's a flat rate of 20 bucks. So there's their flat rate of 20 bucks, and they're charging $10 per hour. So I need to find one that has a y-intercept of 20 and then goes up 10 right 1. So y-intercept of 20, I don't think so. That looks more like a 10. So he's out. Y-intercept of 20, I like that one. Y-intercept of 20. This one actually looks to be somewhere in between 10 and 20. I don't really like that one. Y-intercept of 20, yep, I like that one. Okay, so now my slope is 10. Well, let's figure out what one block represents because we need to go up 10, right 1. Well, if from here to here is 50, and that's 5 blocks, so that means each block is worth 10. So when I want to go up 10, I really now only want to go up 1 block. So up 10, which should be 1 block, and over 1. This one looks to be dead on it. Let's try this one down here. If I go up 1, right 1, it seems to be rising too slow. So we like that one. Becky's husband Daryl heads out on the same path a few minutes later with his dog, Cheyenne. Daryl and Cheyenne average 10 miles an hour. Which graph shows their run? Well, the one graph that sticks out to me that's different is C. Let's talk about what C is saying. Now, C has a horizontal line at 10. But you have to focus on what this represents. This is distance, and this is time. So when he started, he was 10 miles away from home. At hour 2, he was still 10 miles away from home. At hour 4, he was still 10 miles away from home. So what C is saying is that he's 10 miles away from home and he's just hanging out there. He's not moving. He's not getting closer or farther away from home. Well, Daryl and Cheyenne are averaging 10 miles an hour. They are moving, so it can't be C. All right, now they all start at 0 because he's starting 0 miles away from home because he's starting at home. And I need to go 10 miles an hour, so it's y equals 10x plus 0 if you want to write it, but you don't have to put the plus 0 because they're starting at home. 10 miles an hour, so I need to go up 10, right 1. So up 10 would put me here, right 1 would put me there. And that line doesn't work. So let's try it over here on B. Up 10, right 1 would put me there. And again, right 1 happens to be right 2 blocks in this problem. So I like B. Let's look at D. Up 10, right 1. Looks to be a little too steep. So we're going to go with B. So they can get a little tricky with how they're labeling their axis. So just make sure that you pay attention to how much value is in one block. The graph shows the level of water in a lake, which description shows the relationship between the amount of water in the lake and the time that has elapsed since the data began to be recorded. Okay, before we read all this, let's look at our graph. So this represents the water level. So what is the water level starting at? 20. What's happening to the water level? It's decreasing. So I need something that says that the water level starts at 20, so begins at 20, begins at 20, begins at 20, begins at 20. So that doesn't help me. But if you keep reading in A, it says, and is increasing at a rate of 2 feet per hour. It's not increasing. That slope is negative. They're losing water. So it can't be A. This says decreasing, so we get to keep him. This one says increasing, so he's out. And this one says decreasing, so we keep him. So we're down to B and D. The next difference is the rate at which it's decreasing. This one's decreasing at a rate of 2 feet per hour, and this is going half a foot per hour. So let's look. Well, it looks to be down 1, right 1. Down 1, right 1. So does that mean it's decreasing 1 foot per hour? You have to look at what the blocks represent. So from 20 to 18 is 2 feet, and then 1 block sideways on your x-axis is 1. So it's 2 feet down 2, right 1. So I'm decreasing at a rate of 2 feet per hour. So the answer there is B. Jack leaves home walking at a rate of 15 yards per minute. The graph at the right shows the distance Jack is from home depends on the time since he left home. Which graph would be correct if he's walking at a rate of 10 yards per minute? Well, if you think about this, 15 yards per minute, think about a football field. 15 yards per minute. He's walking really slow. So the first time Jack leaves home, he's walking 15 yards per minute. And that's what this one is right here. Because the graph at the right shows the distance that Jack is from home. So here he goes, 15 yards per minute. Okay? But then it says, which graph would be correct if he was walking 10 yards per minute? So now I need to see him walking 10 yards per minute. So would he start at 10? And the answer is no. He's starting at home. So he would start at 0. So I like this one. I don't like that one. And I really don't like that one. So the answer's got to be B, but let's figure out why. 10 yards per minute. So we're starting at 0. Look at it. It goes up 10, right 1. Up 10, right 1. 10 yards per minute. Okay, last one. Jesse's bus ride to school is 5 minutes more than 2/3 the time of Robert's bus ride. Which graph shows the possible times? Instead of just going to a graph, write out your equation first. 5 minutes more than 2/3 Robert. So I need one that has a y-intercept of 5. That's not going to work. I like that. I like that. That's not going to work. So I'm down to B and C. I need a slope of 2/3. So up to right 3. Nope. Up to right 3. Like that one. Again, please make sure that you write your equation out first before you go pick your graph. These are not difficult problems. You just want to make sure that you take your time and don't get tricked.